Lesson 3.5, Arithmetic Sequences as Linear Functions. Our essential question today is how do you write an equation for an arithmetic sequence? Our first vocab word is arithmetic sequence. An arithmetic sequence is a sequence with a pattern involving the same number being added or subtracted over and over. So it's a sequence of numbers, and the pattern going from one number to the next involves either adding the same thing every time or subtracting the same thing every time. Arithmetic sequences are linear, and their general form is f of x equals mx plus b, where x equals 0, 1, 2, 3, and so on. The first skill that we're going to work on is looking at a sequence and figuring out the common difference, which is how much it's going up or down each time, and the next three terms in the arithmetic sequence. So our first sequence has the numbers 1, 5, 9, and 13. So hopefully you notice pretty quickly that going from 1 to 5 means an increase of 4. Going from 5 to 9 is also an increase of 4, and going from 9 to 13 is an increase of 4. So positive 4, or adding 4 each time, that will be our common difference. Then if we continue that pattern, 13 plus 4 is 17, 17 plus 4 is 21, and 21 plus 4 is 25. Our next example is a little bit trickier because we're working with all negative numbers. Negative 3, the number negative 3 is 3 units to the left of 0 on a number line. Negative 5 is going further to the left. So my common difference on this sequence is negative 2. So you can think of it as subtracting 2 each time or adding negative 2 each time. So negative 3, negative 5, negative 7, negative 9, they're all odd numbers. The next one will be negative 11, and then negative 13, and negative 15. Our third sequence, we have some positive numbers and some negative numbers. So we're starting at negative 12, moving to negative 6, then 0, and then positive 6. So this sequence is heading in the positive direction. We're adding 6 each time. So if I continue adding 6, I get 12, 18, and 24. The next sequence has some decimal numbers in it. We're going from 7 to 5.5 to 4 to 2.5. So in this sequence, our numbers are getting smaller. If you're not very good at figuring out these common differences, you can always take 2 of the terms. So I'm going to go way back up to the top. You can always take 2 of the terms and subtract them. 5 minus 1 is 4. Negative 5 minus negative 3 would turn into a chunky plus. So negative 5 plus 3 is negative 2. Negative 6 minus negative 12 also turns into a chunky plus. Negative 6 plus 12 is positive 6. And then on this one, you would have to start with 5.5 and subtract 7. 5.5 minus 7. So 5.5 minus 7 is negative 1.5. So you can use subtraction. You can use subtraction to figure out the next term. You just have to remember, though, that you would take the second term and subtract the first one. So if I continue going down 1.5, 2.5 minus 1.5 is 1. Then 1 minus 1.5 is negative 0.5. Negative 0.5 minus 1.5 is negative 2. You can use a calculator on these, so if you're not very good with negative numbers or decimal numbers, don't worry about it. you can use a calculator. All right, this last one, negative 7.7, negative 5.5, you may notice a pattern here. And then negative 3.3, negative 5.5 minus negative 7.7 turns into a chunky plus. So negative 5.5 plus 7.7 is 2.2. So the common difference here is positive 2.2. Even though they're all negative numbers, they're getting closer to zero. They're getting closer to being positive each time. So the common difference is positive 2.2. So on this one, if I add 2.2, I'll get negative 1.1. Then if I add 2.2 again, I'll get positive 1.1. And then positive 3.3. Now we're switching over to writing equations. So write an equation for the arithmetic sequence. 10, 13, 16, 19. In order to write our equation, we need two pieces of information from that sequence. The first one is the common difference, and then the second one is the first term in the sequence, which would be the value when x equals 0. So, our common difference on this sequence is 3. It's going up 3. And our first term in the sequence is 10. So my equation is f of x equals 3x plus 10. Then I'm going to plug in x equals 0 to make sure, just to make sure that I've written my sequence correctly. So f of 0 equals 3 times 0 plus 10. 3 times 0 is 0. 0 plus 10 equals 10. That is the first term. So I've checked it. My equation is correct. The next one, same thing. Common difference. First term. Okay, the common difference on this sequence. If I go from 11 to 4, I am going down 7. And my first term is 11. So f of x equals negative 7x plus 11 is my equation. Then I'm going to plug in 0. So f of 0 equals 7 times 0 plus 11. 7 times 0 is 0, plus 11 equals 11. So my equation is correct. Two more examples like this. This next one, the common difference, it's going from 4 to negative 2.5 to negative 1 to positive 0.5. So my common difference is going up. I can tell it's going up because it's going from negative to positive. How much is it going up? Well, you can use any of these terms up here. It doesn't matter. You just need two consecutive terms. I am going to look at these two. So if it was negative 2.5 and it went down, it went over to negative 1, that's a change of 1.5. So my common difference is 1.5. I could have looked at these, but some people aren't so good going from negatives to positives. So I kept it with two of the negatives. I just used the 1 because it's easier for me to tell how far 1 is to 2.5 than it is from 2.5 to 4. And then my first term is negative 4. So f of x equals 1.5.
Please go to our live YouTube feed. You can find it on our CDMS website. Look for the YouTube logo at the top right portion of the screen.
So f of x equals 1.5x minus 4. And then again, I'm going to plug in 0 and make sure that I get my first term. 1.5 times 0 is 0, minus 4 equals negative 4. That's the first term in my sequence, so my equation is correct. The last one, 2, -1, -4, -7. If I compare two consecutive terms, -1 to -4, it's getting smaller, so my common difference is going down 3. My first term on this one is +2. So f of x equals -3x plus 2. And if I plug in 0, f of 0 equals 3 times 0 plus 2, -3 times 0. So -3 times 0 is 0, plus 2 equals 2. My first term is 2. Perfect. So my equation is correct. Okay, so in this lesson we focused on arithmetic sequences, finding the common difference, and the next 3 terms to continue a sequence, and then writing an equation for the sequence. The equation represents all of the numbers in the sequence, all of them. I was checking the first term to make sure that the equation worked for the first term. You could check your equation for all of the terms. So if you plug in 0, you get the first term in a sequence. If you plug in 1, you get the next term. If you plug in 2, you plug in 3, and so on. So we could use an equation to find any term in the sequence, any term in the sequence. If we had to find the 50th term in the sequence, we could do that. Or if we had to find the 100th term in the sequence, we could do that. And we could use the equation. We would not have to write out the sequence to extend it to 50 numbers or to 100 numbers. We would be able to plug in a value for x and figure out that term. You should be able to write a summary now, answering your essential question, and check with your teacher on your homework assignment.